This is 2.3 linear functions, part 2. So we left off doing point slope form of a line and also slope intercept. And so that's where we're picking back up right here. Reminding us what point slope form looks like. Oops. Okay, and remember that we literally just plug it in. So here's my slope, there's my m, here's my x1, and here's my y1. So plug it in, y minus, y1 is -7. Make sure that you account for that negative and don't get confused that the subtraction symbol was part of the -7, equals your slope, -3/4. And then x minus x1, it was a +1, so we just plug it in. So remember that we're not distributing anything. We're not going to distribute that -3/4. The only thing that we're going to simplify if needed is if we have a minus negative. So y minus -7 is going to simplify to y plus 7, and then everything else stays put. And that is the point slope form of the equation. And it does feel very unfinished, at least to me it does. I want to do more, but that is the point slope form, so you entered that exactly like that. Then we'll go on to do the slope intercept form of the equation. So I'm going to drop down the point slope form. Oh, don't forget your negative, that'll change things. And now we start distributing things, right? So now I'm going to simplify the right side of my equation by distributing that -3/4. -3/4 times -1 would give me a +3/4. And then I'm going to subtract 7 from both sides. So you could break it down here and write -7 as a fraction, and then write it just by putting it over 1, and then find the common denominator, which would be 4, and rewrite the fraction, all of that. Or you can just enter it into your calculator. If I was to go ahead and do the math of this over here, 3/4 minus 7 over 1, I'm going to multiply that denominator by 4, so that I can now subtract in my numerator, and I get -25/4. Okay, so what do I have left here? I have y left on my left side, which is my key in slope intercept form, and let me go ahead and write slope intercept form here. I didn't write that out. Okay, so y equals -3/4 x minus 25/4. And 25/4 is simplified. You'll leave it as an improper fraction there, as long as you've simplified it. So nothing can divide into 25 or 4 besides 1, then you're done. And that is completely simplified. Sometimes we're not used to dealing with improper fractions as often, and so we feel like we have to put in a decimal or just do different things to try to simplify it. Okay, so here they want us to write the equation in point slope form and in slope intercept form. In point slope form, in that last slide, we were given the slope. Let's actually look at it. We were given the slope, and then we were given an ordered pair. So we literally just plugged it in, right? Because we had a spot for the slope, and then we had a spot for each of the coordinates in the ordered pair. Notice in this problem that they give us 2 ordered pairs, but they still want us to write the equation in point slope form. So the very first thing you're going to do is find the slope of the line. Once you find the slope of the line, well, now you'll have the slope, and then you could choose either one of those points to go ahead and fill in the point slope form. So slope is y2 minus y1 over x2 minus x1. I'm going to write one above the other so I can just be consistent. Doesn't matter how you label them. as long as you're consistent. So my top point, I'm actually making it my second point, and the bottom one, I'm making it my first one. So when I go to fill this in, y2 minus y1, and then x2 minus x1. I get negative 12 over negative 10, and that simplifies to a positive 6/5. All right, so that's my slope. So I'm actually going to write that over here. Slope equals 6/5. And then I'm going to use this as my ordered pair and sort of just forget about the other pair. It does not matter if I use my other ordered pair. It would look different, obviously, because we actually can see what the x1 and y1 is in that point slope form, but my math labs will take both answers. So when I go to plug this in, I'd say y minus y1, and then equals slope times x minus x1. Have some simplifying to do there, right? Because I have minus a negative, so it's going to be y plus 1 equals 6/5 times x plus 5. Now again, if I use the other pair, 5, 11, then it would look like y minus 11 equals 6/5 times x minus 5. And that would have still been correct. It doesn't matter because when you take it to slope-intercept form, it changes into the exact same form, and you might want to try that. So let me go ahead and drop this down. So I can start manipulating the equation to be in slope-intercept form. Distribute this, get y plus 1 equals 6/5 x. I'm going to show you the math over here real quick. 6/5 times 5 would be 5 over 1 as a fraction, right? And then I could simplify the 5's out, or I can just go ahead and multiply across. So I get 30 over 5, which would leave me with 6. Okay, I'm going to subtract 1 from both sides, and I'm left with y equals 6/5 x plus 5. So keeping in mind what slope-intercept form looks like. The more that you go through this process and the more that you write down the formula for each one. So if it says point slope form, I like to write down point slope form so I can remember. I didn't do it, of course, on this one as I'm telling you, but I like to write it down so I can actually see what I'm plugging in, and I can try to eliminate any confusion, or at least some of it. And I like to label, okay, well, it's asking me for the slope, which of my values are the slope? And then same thing for slope-intercept form. I like to write down the formula and then go from there so I can actually see what I'm working towards. All right, so it tells us to give the slope and y-intercept of the line whose equation is given, then graph the linear function. So first let's look at the form that it's given to us in. We see f of x equals 4/5 x minus 8. Know that f of x is just representative of a function. So this is the same as y equals 4/5 x minus 8. Don't let that f of x, that's how we pronounce it, f of x, confuse you. Okay, so if I was comparing this to y equals mx plus b, remember that m is my slope and b is my y-intercept. So 4/5 is my slope. Make sure you don't include the x. That's a common mistake that people will say, oh, my slope is 4/5 x. It's just the coefficient. So 4/5 is my slope. And then make sure you take the sign with you. -8 is my y-intercept. Okay, so the slope is 4/5. And the y-intercept is -8. Okay, so how do we graph this? Well, slope-intercept form gives us a starting point and then how to travel. So we're going to start at -8 on the y-axis. So y-axis, we're going to go to -8. And then remember that slope is rise over run. So since my slope is 4/5, we're going to rise up 4. 1, 2, 3, 4, and then run 5. 1, 2, 3, 4, 5. And there's our next point. And then again, rise up 4. 1, 2, 3, 4, and run 5. 1, 2, 3, 4, 5. Oops, I went too far. Let's try that again. 1, 2, 3, 4, 5. Oh, no. Okay. I was right. Okay, so when you go to graph this, it will only let you graph 2 points, and that's fine. I still recommend graphing in your mind where that third point would be. So that could sort of kind of be like your checker point. Like, okay, was I on the right track? Because if you can't draw a straight line through it, if it doesn't pass through the straight line that you've created with the 2 points it did let you graph, then that means that one of your points are off. Okay, so they want us to graph the following equation in a rectangular coordinate system. So this is our graph. Y equals -3. So students sometimes get tripped up by this because it's not in the form that they're used to seeing. But if I was to make a table of values and say, okay, well, let's see. My only criteria here in this graph is that y equals -3. So no matter what x is, negative infinity to positive infinity, it doesn't matter. It could be -500,000, y will be -3. And x could be positive 850,000 and y will still be -3. So I'm just going to choose any x's. I'm going to choose x's that are actually on this graph. I'm just going to choose 1, 2, 3. And this is my x-axis. This is my y-axis. I always travel left and right when I'm plotting points before I travel up and down. So starting from the origin, 1 to the right for x equals 1, and then y equals -3. So I drop down 1, 2, 3. And then my second, so that was my first ordered pair. My second ordered pair is 2, -3. So 2, starting from the origin, 2 to the right, and then drop down -3, and boom, there's my second point. And then I always do a third one. Again, it's only going to let you graph in my math lab 2 points, but I always like to say, okay, if I was able to graph that third point, would it be on the line I created? So starting from the origin, 3 to the right, and then -3, so 3 down. And look at what line that creates. This horizontal line. Whenever you have an equation that's y equals a constant, so y equals 5, y equals 100, y equals -25, if it is in that form, it will always be a horizontal line, always. And the slope will always be 0, which we saw in the first part of this section. On the flip side, when we have an x equals constant form of a line, it will always create a vertical line. So let's look. If I made a table of values, I'd say, okay, the only criteria is x equals 5. So when x equals 5, y can be anything, right? If y is 1, 2, 3, X is 5, 5, 5 all day long. So let's look at that. Starting from the origin, I'm going to travel right 5 units. 1, 2, 3, 4, 5. And then Y tells me to travel up 1 unit because my ordered pair was 5, 1. Second order pair, 5, 2. So again, I travel from the origin 5 units to the right and then up 2 units. And then my third ordered pair travel 5 units from the origin to the right and then up 3 units. And that creates this vertical line. Always, always will I get a vertical line. Pretend my line's straight. I just backed up from the screen and realized how it sort of veers off at the bottom. But always, always will we get this vertical line. And the slope will always be undefined on these lines. Up here, the slope will always be 0. And if you were to punch in 2 of these ordered pairs into the slope formula, you would see that you would get 0 in the denominator. And remember, if 0 is under the line, meaning the fraction bar, then it's undefined. All right, they want us to rewrite the given equation 2x plus 5y minus 10 equals 0 in slope-intercept form. So slope-intercept form is y equals mx plus b. So notice that one of the key things about slope-intercept form is that y is isolated by itself on the left side. So if that can stand out to you, then you can sort of see where to begin to start manipulating that equation so that it's in that form. So 2x plus 5y minus 10 equals 0. We said that y is isolated on the left side, so I'm going to subtract 2x, and then I'm going to add 10. That'll zero it out, but if I did it on one side of the equation, I have to do it on the other. So now I'm left with 5y equals negative 2x plus 10. But notice I have a positive 1y, so 5y is not going to cut it. I'm going to divide by 5, so that can simplify to a 1. I don't want to subtract 5y, right? Because I want to keep y on that side. I just want to make it into a 1y, and the way that I can do that is to divide 5y by 5. Okay, but because I did it on one side, I have to do it on the other to each term. I get y equals negative 2/5 x plus 2. That 10/5 simplifies to 2. Okay, that's the slope-intercept form of the equation. And then it asks us the slope of the equation of the line is, okay, so remember our slope is the coefficient of that x term, so negative 2/5, and the y-intercept is positive 2. And then they want us to graph it. So remember, this is your starting point on the y-axis, and this is your travel, how to travel. Okay, so starting point on the y-axis is 2, and then it's 2 over 5, but notice that it's negative 2/5, right? So you're not going to make both of them negative, because if both of them were negative, it actually wouldn't be negative 2/5, it'd be positive 2/5, right? Negative 2 divided by negative 5 would be positive 2/5. So as long as you make one of them negative, so negative 2, so instead of going up to the right 5, I'm going to go down 2 and then to the right 5. Down 2 and then to the right 5. And again, pretend that my line passes through all those points. So remember, my math lab will only allow you to graph 2 of those points, but I still would determine where that third point would be, just to make sure that that third point would be on my line that it graphed. Okay, so now it actually gives us a graph, and it tells us that it shows the percentage of a country's adults on weight loss diets. Okay, it says use the 2 points whose coordinates are shown to find the point slope form of the equation of the line that models the percentage of adults on diets Y. So that's what Y is, the percentage of adults on diets X years after 1987. That's important because X stands for the years after 1987. Okay, so that means the 6 right here, that's years after 1987. So that would be in 1993. This is just, we don't need to determine what year it is. It's just so I can make that connection with you, because we will have questions later on where we'll have to determine what the X would be and decipher that information. And so it's important to show you that. And then 14 would be 2001. Okay, but going back to just, they give us 2 ordered pairs, right? And so we know how to find the point slope from 2 ordered pairs, because the first thing we'll find is the slope. We don't have the slope yet, but because we have 2 ordered pairs, we can find the slope. So that's the first thing I'm going to do. I'm going to find the slope. So slope equals y2 minus y1 over x2 minus x1. If you want to look at any of these formulas on the first part of this section, there's some slides that show these formulas. Okay, let me pull my points to 611 and 14.7. Okay, I'm going to make this x2, y2, x1, y1. So going straight down, 11 minus 7, and then 6 minus 14. So I get positive 4 up top, and then I get negative 8 at the bottom. So I'll get a negative 1/2 that it simplifies to. So that is my slope. And now I can use either or of my pairs. I'm going to go ahead and write which one I'm using. I'm going to say, okay, slope is negative 1/2, which makes sense because my graph is falling from the left to the right. So it should be represented by a negative slope. And then the ordered pair I'm going to use is 6, 11. So let me go ahead and label that. X1, X2. And again, I could have used 14.7, the original X1, X2. It doesn't matter now. I'm almost starting like a separate section of the problem, so now I can relabel them. So when I go to plug it in, y minus y1, this is point slope form, equals the slope times x minus x1. I plug it in, y minus y1, oops, I put x2 over here. That is not correct. Okay, so going back over here, it's x1, y1. I don't know why I put x2. Okay, so y minus y1 equals slope, negative 1/2, times x minus x1, 6. And that is my point slope form. They were not very creative, right, when they gave this the name. Point slope form is literally the form that shows the slope and a point. Okay, now they want us to write it in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So I'm going to go ahead and bring my point slope form over here. And I'm going to start simplifying. So distribute to get it to slope-intercept form. Negative 1/2 x, and then negative 1/2 times negative 6 would be positive 3. Then we're going to add 11 to both sides to isolate that y, and I get y equals negative 1/2 x plus 14. Now, when you enter this into the box, notice that it says write the equation in part A in slope-intercept form, and they have f of x. Do not get confused that f of x is the same thing as your y. So in the box, you would just put negative 1/2 x plus 14. Okay, it says use linear function to predict the percentage of adults on weight loss diets in 2007. Okay, so now this is where determining that what the years are comes into play. They're wanting the percentage. Well, the percentage is the y, right? So we're solving for y, but they also tell us the x value, but not exactly. They tell us 2007. So I'm not going to plug in 2007 in for x, right? Because x is years after 1987. So what I'll do is I'll subtract 1987 from 2007. I get 20, and that will be my x. So if you don't catch that at the beginning, that, oh, x is years after 1987, then it might mess you up at the end where it's time to use the function. And we plug this in, so f of 20, because that's my input, that's what I'm plugging in, will be negative 1/2 times 20 plus 14. Solve that out. We get negative 10 plus 14, and then we get, oops, sorry, that was supposed to be an equal sign. We get 4. So in 2007, approximately 4%, according to this function, of adults would be on weight loss diets.